Hello. Let's show an algorithm that reveals the connection between exponential function, rotation and complex numbers. Also let's show why e to the power of pi has anything to do with -1. Imagine that we live in a world that looks like an infinite chessboard. Imagine that we decide where to move next using instructions that consists of 4 values: right, left, up, down. The direction of our movement is calculated like this. We build 4 vectors: right, 0, minus left, 0, 0, up, 0, minus down, find their vector sum, and that will be our movement direction. Let's also call the sum of all components of those vectors total mass m. Total mass equals right plus left plus up plus down. Let's describe our current state by writing those 4 values separated by commas inside parentheses, right, left, up, down. Let's assume that our initial state is 1 0 0 0. And therefore we move right. We will change the direction of our movement by rotating it counterclockwise. For that we will be adding vectors that are perpendicular to our current movement direction and therefore rotate the direction of movement by the same angle each time. Let's start with 45 degrees. On the first step we increase value for direction up by 1. As a result our state is 1 0 1 0, our direction is rotated 45 degrees counterclockwise, our total mass equals 1 plus 0 plus 1 plus 0 equals 2. On the second step we will have to rotate all the mass we get after the step 1. For that we need to increase values for directions right and up by 1 each. After that our state is 1 1 2 0, our total mass equals 1 plus 1 plus 2 plus 0 equals 4. And we've rotated our direction of movement 90 degrees counterclockwise in total. As we continue, our mass grows exponentially. Here is the algorithm used to make each rotation. You can see that we use value of direction right to increase value of direction up. We use value of direction up to increase value of direction left. We use value of direction left to increase value of direction down. We use value of direction down to increase value of direction right. The multiplier constant describes the rate of total mass growth. In our first example the multiplier constant was equal to 1. We can repeat the same sequence of actions, but rotate by smaller angle each time. If we rotate by smaller angle, the total mass needed for rotation grows, but not infinitely. There is an upper limit of total mass needed. Quite fast we will find out that as soon as each angle is small enough, the total mass needed to rotate our direction of movement 90 degrees counterclockwise, appears to be approximately equal to 4.81. And this is the value of e to the power of pi divided by 2. Why that happens? First I should mention that pi divided by 2 is an angle in radians that corresponds to 90 degrees. Angle in radians is defined as the length of the arc divided by the radius of the circle. 2 pi radians corresponds to 360 degrees. Pi divided by 2 radians correspond to 360 divided by 4 equals 90 degrees. Let's assume that we want to rotate our direction of movement x radians counterclockwise within n steps, where n tends to infinity. For that we need to rotate our direction of movement x divided by n radians counterclockwise on each step. And we need to repeat that n times. Let's assume that our initial state is 1 0 0 0. We will have to increase the total mass by x divided by n on the first step. As a result we will add a perpendicular vector and rotate the direction of movement x divided by n radians counterclockwise. The total mass after the first step will be 1 plus x divided by n. And mass increase is the same, 1 plus x divided by n. The second step is the same as the first, therefore after the second step the total mass will be 1 plus x divided by n squared. After n steps the total mass will be 1 plus x divided by n to the power of n. From mathematics we know that 1 plus x divided by n to the power of n equals e to the power of x, where n tends to infinity. So to rotate the direction of movement by x radians using the described algorithm, we need to spend e to the power of x times more mass than we had initially. Therefore, to reverse the direction of movement using the described algorithm, we need e to the power of pi times more mass than we had initially. After applying that mass, we can be sure that the direction of our movement is reversed. And that's why e to the power of pi has anything to do with -1. You can see yourself that when the direction of movement is reversed, the total mass spent appears to be equal to e to the power of pi equals approximately 23.14. Now let's show what all of that has to do with sine, cosine and complex-valued exponential function. Total mass is growing exponentially because we are adding more and more mass each time. As a result, we get a lot of mutually exclusive instructions, up and down, left and right. Those instructions do not affect the direction of movement as they cancel each other when we calculate vector sum. We can check what is the difference between the values of right and left, up and down on each step of execution. And we will find out that those differences almost match the values of cosine of x and sine of x functions, where x equals the value of the multiplier constant multiplied by the amount of rotations already done. And the smaller is the multiplier constant, the closer are the values. From Euler's formula we know that e to the power of ix equals cosine of x plus I sine of x. Which means that the values we get approximately match the values of complex-valued exponential function for each x. Of course we can try to prove that mathematically, but maybe some other time. At least we have evidence that values that appear as a result of algorithm execution match the values of the cosine and sine functions. Now you can have an intuition on what complex-valued exponential function really describes. It describes the result of our algorithm execution, but when the directions that cancel each other are not taken into account. I will review complex numbers in a separate video. Another similar algorithm exists, but it's not as intuitive as the described one. I will review it in one of my next videos. I'm not sure if you understand what I'm speaking about or not, but I'm doing my best. In this video we've shown how exactly exponent function is connected with rotation, sine and cosine functions. The algorithm described above connects them. Why it's important? Well, because I could not find any as intuitive explanation myself when I was trying to understand why e to the power of pi has anything to do with -1. The explanations I could find were showing how to prove that e to the power of I pi equals -1, but did not provide explanations why. I don't know if you need the answer to the question why, is it important for you or not, but as a programmer sometimes I just can't accept not understanding the logic. Maybe because it's really hard to use code when you don't understand what happens in it. So I could probably call it my force of habit. To not avoid the why question. That's how programmers are different from modern physicists, for example. Modern physicists are trained to avoid asking why. They are trained to ask, according to which mathematical formula it happens? So it seems that whatever I've described in this video will not make any sense for physicists as it's not a part of their formulas-based universe. Their universe starts with the exponential function or some other function. Not earlier. But that does not have to be true. Of course, the need to know why is not the only reason to investigate the connection between the exponent function and rotation. Answering the question why some part of the system works the way it works can give us additional insights on how the whole system works. You see, I believe that mathematics is not only some language that humanity uses to communicate. Many people seem to think that way. No, it's more than that. The functions we use are not just random functions, they were not just invented. They were discovered, and the ones that are used in physics are used because they describe the true nature of our reality. In one of my previous videos I've described assumption that physics is a branch of mathematics, extended statistics. Link to that video is in the upper right corner now. Well, it works both ways. If physics is a branch of mathematics, then mathematics can be compared to physics in some sense. I don't know How obvious was whatever I've described today? But even if it is, it's not the end. Thank you for your attention.